right, so next up we have Bea and Hank, and we are going to be learning about using ONNX models with ML.NET. So I'll turn it over to you folks. I think, do you have a presentation share? Yes, you do. Okay. And let's make sure your mics work.
Hello.
Hello.
Can you hear me?
Awesome. Okay, you sound great. I will turn it over to you. Have fun.
All right. Hello, everybody, and welcome to our presentation on machine learning models with ONNX and .NET. My name is Bea Stolnitz, and I'm a principal cloud advocate at Microsoft, and I'm here with my colleague and friend, Hank.
Hi, everyone. Yes, I am Hank, senior cloud advocate and colleague of Bea. We're in the same team. And I'm super excited to talk to you today about .NET and ONNX. So today, our presentation evolves around a demo. We start with a dataset with a lot of Lego figures in it. And we're going to create a model. That is where the question mark is, because we're going to explain you how to do that. And then run that model in a .NET MAUI application that should be able to run on this mobile phone at the end of the presentation. But before we start, I wanted to hand over to Bea to set kind of the stage, because there are a lot of parts involved in creating this AI model.
That's right. And we're not going to assume that you have any AI background in this. So we're going to start from the beginning and give you a quick overview of what AI is about and of some of the techniques that you're going to be seeing in the demo. So what is AI? It's a simulation of human intelligence by machines. And this definition, at least to me, it sounds like super futuristic, like we're living in the sci-fi world in the future. But it's actually been around for a long time. And actually, specifically in 1950, Alan Turing came up with this paper. He wrote this paper on how to build intelligent machines. You can see his photo in the slide. And since then, we've had AI summers and AI winters where there's been lots of excitement about AI or lots of disappointment and people thinking it's not going to go anywhere until today, right? And today, AI is everywhere. For example, if you get a package in your house, there was some AI that helped the address to be recognized and directed to the right location. If you're on social media, the ads you see, there's certainly some AI there that will determine which ads are right for you. If you go to the bank and get a loan, some AI is going to help decide whether you should be getting that loan or not. So it's everywhere, even if we don't live in this futuristic world. And so one term that has been used interchangeably with AI more recently is machine learning. So a lot of people use these two words as if they were the same, but they're not technically the same. Machine learning is really the ability to learn without being explicitly programmed, and it's a subset of AI. So if it's a subset, you might wonder, what else is there in AI other than machine learning? Well, there's many other methods. For example, expert systems, which in which experts will add knowledge to a system, over time, and then users will be able to extract that knowledge and kind of extract advice from those systems. That's just one technique that isn't as used today as it used to be, but it certainly used to be very widely used before. So assuming that we're all programmers here, right? When you're programming, generally, the mental model that you have in your mind is that you're going to be writing an algorithm, you're going to be writing code, and you have some data that goes with that code, and then you produce an answer. So for example, you might have some database with SQL contacts, and then you write some code that extracts contacts based on some term that people type, and then it will produce the answer, which will be the right contact that matches that term. So that's something we're all familiar with. So I just want to start here because I want to compare with how does this relate to machine learning? How is machine learning different, right? So machine learning, just typically speaking, it switches the algorithm with the answers. And it's a little bit mind-bending if you haven't worked with machine learning a lot, but that's just really what it is. Instead of you writing the algorithm from scratch, you just get some data, for example, some images of cats and dogs. You get some answers, which in this case would be the labels for this image, like whether it's a cat or a dog. And then machine learning will produce that algorithm. It will produce some code. Except in machine learning, we don't call this thing an algorithm. We call it a model. That's basically what it is. The model is your algorithm that can predict new things based on input, right? So this phase that we're looking at here, this little rectangle, really corresponds to the training phase of machine learning. And machine learning generally has another phase, which is the prediction phase. And so in the prediction phase is a little bit more familiar, more typical of like, or more similar to traditional programming, because you get that model or your algorithm as input, and you get some data that the model hasn't seen before, for example, an image of a new cat, and then it gives you an answer or a prediction. So in this second phase, it's very much similar to traditional programming, except you didn't write the model. You didn't write the model. So the model was generated from answers and data. And why is this different or better? It's not better, it's just different, I would say, because it enables us to solve problems that aren't easy to solve with traditional programming. Typically cases where you have lots of different edge scenarios and, you know, where you would do like a million if-else statements throughout your code, those can be really error-prone and time-consuming to write with just by traditional code. But with machine learning, they're really easy because you can generally get enough data and answers that will produce that model for you automatically. And specifically, we're seeing huge benefits in language understanding and computer vision. So next I want to talk about deep learning, because the demo that we're going to be seeing is going to be using deep learning. So what is deep learning? So it's a subset of machine learning that's based on artificial neural networks. So again, this is a subset. So what else is there in machine learning other than deep learning? Well, there's statistical learning, there's genetic programming, there are many other techniques that are still very much in use today other than deep learning. But deep learning seems to be getting a lot of attention lately. And the reason is that deep learning works really well for big data. And we live in the age of big data because it's so easy to extract lots of data from the internet these days. And so that's why deep learning has been doing so well and why people have been so excited about it in recent years. And you may, so in our definition, it says that it's based on artificial neural networks. So what does that mean? Does that mean that it's based on the brain, on artificial neural network or neural networks? And it actually is. It's not exactly like the brain, but it certainly is inspired by the brain. And this is one of those scenarios where we see like a really, really cool overlap between two areas. So you have like neuroscience that studies the brain, and then you have AI or computer science, that just came in and took inspiration from this amazing field and took those techniques and just these early pioneers just thought what would happen if we implement these things that we know about the brain in a computer. Like, could we simulate what the brain does? And of course, deep learning is not exactly like the brain. It will perform much worse than the brain in some things, but it will also perform better than the brain in other things. So there's certainly here like a compromise that we're getting, but it certainly has been producing good results. So it's a very cool kind of thing that happened between these two fields. And so our demo is also going to be using computer vision in particular, right? So what is computer vision? Computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world. And there's many things that you can do with computer vision, classification being one of them, where you give the computer images of cats and dogs, and then the model will tell you, oh, this is a cat. Classification and localization is another thing, where in addition to telling you what it is, it will tell you where the cat is in the image. Object detection, where it can detect several objects within the image. Image or instance segmentation, where actually will tell you the outline of each object. So these are all like varying levels of like kind of sophistication in computer vision. But for this demo, we're going to stay with the classification scenario, the one on the left, which is the simplest one. So that's what you'll see in the demo. You're going to also be seeing transfer learning in this demo. And so what is transfer learning? In transfer learning, a model trained for one task is used as a starting point for a different task. So for example, you could train a model on images of drinks. And then later, if you want to identify foods, you could take that model as kind of a starting point, and then add a little bit more code to it, add a few changes to it, and then that model can classify images of foods. And like this is used a lot recently because it just saves a lot of time in training the model, because you're getting a model is already like almost there, and then you just train it a little bit more, and then you get what you want. So this is definitely a technique that is used a lot, and you're going to see it in our demo. So there's lots of different frameworks that people use to do machine learning and deep learning. In our case, in this demo, we're going to be using PyTorch. So PyTorch is an open source deep learning framework, originally developed by Meta AI and now part of the Linux Foundation. So you'll see that there are lots of frameworks for all sorts of AI techniques. You'll have frameworks that do genetic programming, frameworks that do statistical learning. But in this case, we're using deep learning. And even within deep learning, there's many frameworks that do deep learning. But Henk and I like PyTorch, so that's what we chose for this demo. And we're also going to be using another very cool framework, which is ONNX. So ONNX is an open format built to represent machine learning models. It defines a common set of operators and a common file format to enable AI developers to use models in a variety of frameworks. So the interesting thing in this definition is that it defines a common file format. And what it's going to enable in our demo is that it's going to allow us to use PyTorch, just straight up PyTorch, to create our model, and then save that model in ONNX, and then read that model from within .NET MAUI, because ONNX makes it work. It's a common file format that makes it work across frameworks. And so that's what makes it so cool. So I think we're ready. I think we have all the knowledge we need to understand what we're going to be seeing and to understand this demo. So I'm going to pass it back to Henk, who's going to be telling us in more detail what we're going to be seeing in the demo.
Cool, thank you. Okay, that was a lot of information and a lot of terminology, and we're all going to use that where we see the question mark now. So what we need, like some kind of tool to build this AI model. So we are going to use Azure Machine Learning for that. And Azure Machine Learning is a really great tool for working together on machine learning workloads. So like you work together on regular .NET code, you also have to work together on machine learning code, on writing the algorithm, and that is what Azure Machine Learning enables you to do. So what is Azure Machine Learning? So Azure Machine Learning is a set of cloud services. It's not just one single thing. It is a container registry. It is a key vault. It's all these services that really work together and are controlled by a Python SDK. And on top of that are built like a few tools to control that again and make things easier, like Azure Machine Learning Studio, the whole experience. You can control it from a notebook. You can use automated machine learning, the CLI from Visual Studio Code. So there are many ways of interacting with that set of cloud services through that Python SDK. And it really enables us to prepare our data, to track our experiments, manage models, train models, and in the end, even deploy our models in managed endpoints. So Azure Machine Learning has a few key elements that we really need to know about. So there are experiments. That is where all the information is gathered about your kind of experiment, kind of your run training phase you're doing. There are data stores where our data lives, and our experiments need to access that. There are environments where we're going to train our models in, and that is model management. And model management is kind of the key in this story. We are going to train our model in PyTorch and eventually register that in model management. Then later on, everyone can kind of check out that model from model management and use that in the software of their choice. So you can kind of compare it when you have like kind of a NuGet package that does a thing, is in the NuGet repository. So you can also pull out models from Azure ML model management. So, and this is how it looks. If you go to ml.azure.com, you can go to your Machine Learning Studio. For our training, we're going to use a machine learning pipeline. So what is a machine learning pipeline? A machine learning pipeline is a workflow of steps that can use data sources, data sets, and run on compute targets. So let's zoom into a step, or in Azure Machine Learning world, a component. So a component can run a script on a compute target in a Docker container. It takes in input and it generates output. And you can control that script with parameters. And if you combine those components, you get a pipeline. So the pipeline we are going to build originates from a blob storage account where there is a big data set of Lego images. Then there is a component that is going to train the model using PyTorch, and that step or component will deliver us a model. Then another component will pick up that model and convert it to ONNX and deliver us an ONNX model, which the last step will kind of register the model in model management. To create a pipeline, we're going to use the Azure Machine Learning Designer. And this is a really cool tool because everything you do is very visual. But you can also create these pipelines using Python or using the Azure CLI v2 and specify everything in the YAML format. So, time for the demo. So let's see if we can get our application up and running and classify some Lego. So here we are in our Azure Machine Learning Studio, ml.azure.com, and I'm here in my workspace. On the left, I have all my tools, and on the right, I have my dashboard. So the first thing what we're going to do is every machine learning project starts with data. So the first thing we're going to do is take a look at the data. So this data is on a blob storage, and here under data sets, we can kind of explore that data set. Can click on the image, it will load, and it will show us here is there are around 500 images in this data set. So the next thing I'm going to do is I'm going to go to Designer. I'm going to create a new pipeline, custom, create a new pipeline, and I will start with dragging up the components on the canvas. So we start with a Lego characters data set, and then I'm going to drag my components on it. So the first thing we start is with training the PyTorch model. Then we're going to convert it to ONNX, and finally we will register it. And I can connect all these outputs with the inputs, and here we go. So I'm going to click on one of the components and specify a parameter. We tag this model as a .NET-conf, and I'm going to specify that it has to run on my Azure Machine Learning compute that is called Bumblebee. I'm going to save my pipeline and submit it, but before I have to select under which experiment it has to run. And this is called Lego classification. So I will submit it, and hopefully in a few seconds, our job will start to run. So the job should take 2.5 minutes. So in the meantime, we can take a look at how a component actually looks. So we will go to components here, and here we see our 3 components. We can click on them. We can kind of see which versions of the components are there, which code is there behind, and in which job these components are being used. So let me see if in here on the jobs, you can click on the job, and we can see that our job started running luckily. You can create these components using this button here, notebooks. You can create notebooks here, but you can also create other code here. So let's take a look at the component definition. So we start with defining the schema. Then we have a name. We specify our inputs, our outputs, where our training code is, which environment it has to run on. And here is where the magic happens. But is it really magic? It is just executing a command, Python train.py. So let's take a look at the training file. This is the file I've got from B. So I'm going to try to explain it. And if I'm doing it wrong, B, please tell me. So the first thing we do is make sure that we can handle incoming parameters. Then we're going to shape our data. We're going to divide it into a training or test and train set. We are going to download our pre-trained model. So we can do that transfer learning thing he was talking about. It's a ResNet 18 model. Then there is a lot of code I don't understand. We will train the model, and we will eventually save the outputs. We save a labels file and a model file. And it's kind of good to know. the model is actually just like one file, but here it is still in PyTorch. So in the next step, we kind of convert it to Onyx, and then finally we will register it. And if this is 2.5 minutes, I've talked about components, our model should have been trained. So let's click here, and no, it is not yet, but let's see where it is. It is in the registering the model phase. So here we kind of see what it has done. We can also click on these models, on these steps, and kind of see the metrics the model have generated. But we see the model is registered. So now we should be able to see this model here in Model Management, version 9, 850. It has been registered. That is my time here in Amsterdam. So what we can do now is we can get that model out and use it in our .NET application. So this is my .NET MAUI application. So I've created a new project and kind of left everything like it is. So I have here an old model. So I will delete that from here, from the assets. And I will go to Visual Studio Code and will execute the command to download our new latest model. Model is around 44 megabytes, so it should be downloading quite fast. And we see it is here now. And then we're going to copy that model back to our solution. And we should be able to see here now the two new files. So what I will do before I dive into the code is I will actually run it, because it will take a while to deploy to my phone. And then I will go through the code. So I will do that now. So in the constructor, I will load the labels and will load the model. Loading models takes time. So you basically want to only load the model once, load in the function once, and then run data through the model. You don't want to do that on every request. So I'm loading the model from the package, loading the labels, and then I have a button that will take a photo using the media picker. I'm opening that photo. I'm resizing it to the exact same shape that we specified in the training script. So the image has to be 224 by 224 in RGB colors, red, yellow, red, green, and blue. Then I predict, run it through the model. There's one function here, and then I will draw the result on the screen. Diving into this predict function, what does it do? It loads in a model. It creates a shape, 3 layers, RGB, 224 by 224. This model really likes that you have the values between 0 and 1, and not between 0 and 255. I create an input for it and run it through the model. And then I take the first result with the highest probability. So our application is loaded. I'm starting up my mobile phone. We see the screen here. It is really here. We're taking a photo of Krusty the Clown.
Krusty.
And hopefully the model we've trained is going to say, yes, that it is Krusty. It's not too sure today, but it probably comes because there's all my fingers there next to it. But it is working. So that kind of concludes our presentation for today. So what did we actually build and talked about in this 30 minutes? We started with like kind of this Lego data set on a blob storage, and then we created that model. We have Azure Machine Learning. We use that to train in Python a PyTorch model. We converted it to Onyx, put it in model management, that our application could use that model using .NET code. So the data scientist can do his or her job in the language of choice, and the developer can build the application in his or her language of choice. All the code, this sample code you have seen, is available on the link you're seeing here. And there are also some useful links to learn a lot about machine learning if you go to B's blog with this link there, or if you want to learn a little bit more about like more the AI developer role, you can go to my blog and read some more articles there. So thank you all for your attendance and presence. And back to
Thank
you,
you,
Joe.
everybody. Yeah. Thank
Wow,
you.
that was awesome. A lot of people loving that in the comments. We didn't have any direct questions. So one thing I was wondering about, you showed that on a mobile device, and that was using a model. I, like, not knowing the space, was worried that like the ONNX model would be a large file. How should I think about that? Like, what makes a model large, and how do I control that?
I would say that generally models aren't very large. There are techniques, lots of, very kind of advanced techniques to make them even smaller and make them work even better on mobile. For situations where you really, really need to kind of extract, all little bit of like performance out of it, or size, out of it. So there's actually a huge area of deep learning, or really machine learning right now, is to really try to reduce those models, those deep learning models, and make them like tiny, even if it's like sometimes at the expense of performance. Sometimes it's actually more important that they're tiny than that they give you, 99% accuracy. So, but in this case, what you saw, we didn't do anything special. There are no tricks in this demo. It's really just a plain old model that we trained with the easiest, most basic techniques that we could find. And it worked, as you saw. Like, it just works on mobile.
Yeah.
So.
This one was 44 megabytes.
Okay. Wow, that's tiny. I mean, really, to put it. Okay, are there other things that, like, this was a great idea for a demo. Are there other things that you've seen community do, or other things that you've thought of as ideas, or neat experiments you've done?
We need to save our ideas for the next .NET conference. We can't just use them all here.
Oh, wow. All right. And I think, so you shared some great resources. And gosh, I'm trying to think if there's anything else we should talk about. Anything else you'd like to share with folks?
Yeah, I think one thing will lead kind of next to I see Rory already in the backstage, so that will probably be a talk about accessibility. So a really cool project, I'm not going to steal all Rory's thunder, is like this app, this Seeing AI app, where all these things come together, like all these different AI models that you can do in a mobile app. So
Okay.
if you didn't hear about Seeing AI, go and listen probably to Rory's talk, or look it up if he's not going to talk about it on the Microsoft website.
Okay. Actually, I'll just bring Rory on. Are you going to be talking about that, Rory?
I am not going to be talking about that, but I do agree with Henk to actually go look at the Seeing AI app. Henk and I actually lead advocacy for the developer advocates at Microsoft. So we work together, but he didn't have to go before me, because now I have to actually beat him on this incredible talk that he just did.
Wow. Yeah. Yeah. Well, great stuff. So thank you again, Henk and B.